Oxygen is continuously supplied, excess of oxygen is supplied, and heat is also provided. That means we are burning the organic compound. Once we get to know about the mass of carbon dioxide, we can calculate the percentage of carbon present in it. What does nitration of benzene means? Yes, we are going to add NO2, nitro group, to a benzene ring. In staggered conformation, hydrogen atoms will be present as far as possible or at maximum distance. Now in eclipse conformation, these hydrogen atoms will be close with each other. Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysore. So today I'm back with session 3 of the model paper discussion. So in the last session, we discussed the part C of the model question paper. In today's session, we are going to discuss part D of the model question paper. So part D consists of 5-mark questions. So out of the following questions given, you only have to attend 2 questions. Okay, answer any 2 of the following questions, and each question will carry 5 marks. So a total of 10 marks you will be getting from this section. Right. So let's begin with the first question, 41. What is the type of hybridization of carbon atoms marked as A, B and C in the following compound? So compound is given to you, carbon atoms are marked A, B and C. You have to calculate the hybridization. Second part, what is carbocation? And write the decreasing order of stability among primary, secondary and tertiary carbocations. So how the mark distribution is done here is 3 plus 2. That means the first part, A part will give you 3 marks and B part will give you 2 marks. So A part will carry 3 marks, means if you identify the hybridization of A, you will get 1 mark, C you will get 1 mark, B you will get 1 mark. So a total of 3 marks there. And what is carbocation? The definition for this, you will get 1 mark, and the order if you write for primary, secondary and tertiary, you will get another 1 mark. So total of 5 marks from here. So let's begin with the A part, right? So you have to calculate the hybridization of each carbon atom. So let me write down the compound here, CH3, CH, double bond C, double bond CH2. So this is A, carbon atom A, this is C and this is B. So what is the easy method to calculate the hybridization of carbon atom? Yes, it is to calculate the total number of atoms, other atoms it is surrounded by. So for example, if we are calculating for this carbon atom, we have to identify the hybridization of carbon atom A. We have to see how many other atoms it is surrounded by. You don't have to consider the number of double bonds or triple bonds. Just you have to count the total number of atoms it is surrounded by. Okay, so this carbon atom, it is further attached to 3 hydrogen atoms as well as this carbon atom, right? It is attached to these 3 carbon atoms and also to another carbon atom. So there is a total of 4 bonds which it is forming. So it forms sp3 hybridization. So this is how you can easily identify it. So S, 1s and 3p. So that gives you a total of 4. Okay. Now let's move on to the carbon atom C. How do you calculate? The same way? This carbon atom is attached to this hydrogen atom, 1, and this carbon atom and as well as this carbon atom. So a total of 3 atoms, right? So it becomes sp2. That is 1s and 2p will give you 3, right? So there also you don't have to consider the double bonds, just calculate the total number of atoms, right? Moving on to B, you can see 2 hydrogen atoms and 1 carbon atom which is adjacent to it. So again this will be also sp2. Okay, so carbon atom A, sp3 hybridization, B, sp2 and C, sp2. So I hope this method is clear for you. You just have to count the total number of atoms it is surrounded by, and based on that you can assign sp3, sp2 or sp. I hope it is clear. Now moving on to the next part of the question. What is carbocation? A carbocation is a molecule in which a carbon atom has a positive charge and 3 bonds, right? It will be having 3 bonds. That is why it is having a positive charge, right? So it is having 3 other bonds and it is having a positive charge. That is why it is called as carbocation. So this carries 1 mark. Now the next part is you have to write the decreasing order of stability. So the stability of primary, secondary and tertiary carbocation is given as tertiary is having the highest stability, then secondary, then tertiary carbocation. It is explained on the basis of inductive effect. Greater the number of alkyl groups attached to the carbon atom carrying the odd electron, greater is the delocalization of odd electron, and hence more stable is the carbocation. So the question has not asked you for the reason, it has just asked What is carbocation? Yes, we have already discussed that. And what is the order of stability? So it is tertiary, secondary and primary. So this order is very, very important. Okay, I hope it is clear. Moving on to the next question, 42. Again, for this also you have two parts. Okay, so here the marks distribution is different. There it was 3 plus 2. Here it is 4 plus 1. Right. So you have to check the mark distribution as well. Okay. So now the first part is explain the principle and calculations involved in the estimation of carbon in the organic compound. That means how do you estimate carbon in a given organic compound? What is the principle and calculations in detail you have to write for 4 marks. Right. The second part is what are electrophiles. So first part, that is the estimation of carbon, the principle and calculation. So a known mass of organic compound is burnt in presence of excess oxygen and cupric oxide. Carbon and hydrogen in the compound are converted into carbon dioxide and water. The masses of carbon dioxide and water produced is determined from which the percentage of carbon and hydrogen are calculated. So this is the principle, right? We take the organic compound and what we are going to do? We are going to heat it in presence of excess of oxygen. So you can see the picture here. Yes, here we have taken the sample. Okay, and we are going to heat it in presence of excess of oxygen. So heat is supplied from here, the oxygen is supplied from this side. Okay, so oxygen is continuously supplied, excess of oxygen is supplied and heat is also provided. That means we are burning the organic compound. Now what happens? The carbon present in it will be getting converted into carbon dioxide and hydrogen what is present in the organic compound will be converted into water, right? Once it is burnt in excess of oxygen, carbon dioxide, carbon forms carbon dioxide, hydrogen forms water, right? Carbon forms carbon dioxide and hydrogen forms water. Now what happens? It will pass through this tunnel and what happens? That is, in this tunnel you will have cupric oxide, CuO will be there. So it will pass through the cupric oxide and what will happen? You have two U tubes which is present here. Anhydrous calcium chloride will be present in one U tube and in another U tube you have potassium hydroxide. So what happens as the carbon dioxide and water is passing through this tunnel and it reaches the U tube, the carbon dioxide will be absorbed by the potassium hydroxide solution and the water will be absorbed by the anhydrous calcium chloride. Okay, so before starting the experiment itself, we are going to measure the amount of anhydrous calcium chloride and potassium hydroxide solution. Now, after the experiment, what happens? Yes, water will be absorbed here and carbon dioxide will be absorbed in the potassium hydroxide solution. Now, after experiment also we can measure. So, that difference will give you what is the mass of water and what is the mass of carbon dioxide which is evolved. I hope it is clear. So, that way we can calculate the amount of carbon dioxide and amount of water being produced or which is present in the organic compound. So, I hope this is clear to you. Now, coming on to the calculation, once we get to know about the mass of carbon dioxide, we can calculate the percentage of carbon present in it. So, how do you calculate the percentage of carbon? It is 12. That is atomic mass of carbon into M2. That is how much of carbon dioxide is formed into 100 divided by 44 into the mass of the organic compound which is taken. So, in this way, if you calculate, you can find out the percentage of carbon. So, in the question, if for hydrogen also it is asked, then you can use this percentage of hydrogen. It is 12 into M1 into 100 divided by 18 into the mass of the organic compound. So, I hope it is clear. So, this is how you do the calculation and this is the principle and the steps that follow. So, I hope it is clear in detail. Now, moving on to the next part, what are electrophiles? Okay. So, from the name itself, you can see electrophiles. So, those are those species which are having attraction towards electrons or else negatively charged species in general we can say, right? So, electrophiles are those species which are having attraction towards negatively charged species. So, they themselves will be positively charged, right? Okay. An electrophile is a chemical species that accepts an electron pair and forms bonds with nucleophiles. Electrophiles are Lewis acids. They are Lewis acids because they are ready to accept electron. As I said, they are positively charged. So, positively charged species will be having attraction towards negative charge. They are ready to take up electrons. Hence, they are Lewis acids. Now, most electrophiles are positively charged, have a partial positive charge on an atom or have an atom without an octet of electrons. So, they are generally positively charged. Hence, they will have attraction towards electrons and they are ready to accept electrons. Hence, they are Lewis acids. So, this will carry 1 mark, a total of 5 marks from this question. Right. Moving on to the next question. An alkene A on ozonolysis gives a mixture of ethanol and pentane 3-on. Write the chemical reaction and IUPAC name of A. So that carries 3 marks. And the next part is explain Wood's reaction with a suitable example, which gives you 2 marks. Okay. So the first question, let's discuss an alkene. Okay. It is given A, which is an alkene. Okay. So your answer should be to find what is A. Right. And you have to write the IUPAC name of that. So an alkene A on ozonolysis gives a mixture of ethanol and pentane 3-on. So after ozonolysis, what are the products formed is already given to you. So from that products which is formed, you have to identify what exactly is the reactant which you have taken. Okay. So we have A, which I don't know. It undergoes ozonolysis, and what are the products formed? That is given there, ethanol, CH3CHO. One product is ethanol, another one is pentane 3-on, right? What is pentane 3-on? CH3, CH2, C double bond O, CH2, CH3, right? So these are the products which is formed as given to you. So now from the products which is formed, how can you identify what is the A that we have taken? Okay, so once ozonolysis is taking place, that is A undergoes ozonolysis, an intermediate stage is formed which is called as ozonide, right? So first if we write down the ozonide, we can identify which is the alkene which has been taken. So you can see here, this can be also written as CH3, C double bond O H, right? It's the same, CH3, CHO. So as you can see, the oxygen, it is present here and here. So that means that there is a double bond between this carbon atom and this carbon atom. Okay, that we can identify. So I'm going to write down the ozonide for this, from which we can identify. So let's begin with the ethanol, CH3CH, and you have an O here, and the other carbon atom, you have one more O here and one more O here. So after ozonolysis, the ozonide which is formed, I am writing. So this CH3CH is from this ethanol, and you have the other carbon atom, which is this particular carbon atom, you can see. Okay, the double bond is formed between those 2 carbon atoms. Now what else is there? You have one CH2CH3 here, right? Another CH2CH3 here. Okay, so this carbon atom, on this side you have CH2CH3, right? And another side you have CH2CH3, which I have mentioned here. So this is the ozonide which is forming. So this ozonide will break in this format, and what you are going to get? CH3CHO, one product, and another product is CH3CH2, C double bond O, CH2CH3. So this is how the compound is being formed, okay, after ozonolysis. So if this ozonide what I've written is correct, then easily we can identify which is the alkene. My question is to find out what is the alkene, right? So what will be the alkene? As discussed, the double bond will exist between this carbon atom and this carbon atom. So it will be CH3, this CH3, then you have a CH here, and a double bond is present between this carbon atom and this carbon atom. Now after that, what you are having attached to this carbon atom, you have one CH2CH3, and to this carbon you have CH2CH3. So 2 ethyl groups are attached. So I hope it is clear. So this one I have mentioned here, and this one I have mentioned here. So this is your A. So to this alkene, when ozone is added, ozonolysis takes place, what happens is double bond is broken, and the 3 oxygen atoms will be attached in this format, which is the ozonide. So I hope it is clear. So this is the alkene. So we have identified which is the alkene. Now we have to name the IUPAC name here. So let's begin from this side itself. So it is 1, 2, 3, 4 and 5. So 5 carbon atoms are numbered, and on the 3rd carbon atom you have a CH2CH3. What is CH2CH3? It is ethyl, right? So 3 ethyl. So what is the root word? It is pent, and on the 3rd carbon atom you have a double bond. Okay, so what is the IUPAC name? It is 3 ethyl, right? See, this is 3 ethyl, and you have pent, and on which carbon atom the double bond is here? 3rd carbon atom, pent 3 ene. Okay, so I hope this is clear for you. So this is how you have to do the question. Okay. So now moving on to the part B of the question, explain Woods reaction with a suitable example. So Woods reactions are used to produce ethane from methyl chloride. So from methyl chloride, that is from alkyl halide, how you can form an alkane, right? Ethane and sodium chloride are generated when methyl chloride interacts with sodium metal in the presence of dry ether. So it is important to write the reagents and the reaction as well as which is the catalyst is being used. Okay. So this is an alkyl halide which is represented here in general RX, right? Okay. An example they have asked. So we can write RX, which is general formula, to which sodium is added in presence of dry ether, and one more molecule of RX we have taken. So this R and this R are different. It can be same also. So that is why it is mentioned as R and R dash. So now what happens? This much part will be removed as 2NaX, sodium chloride or sodium bromide, whichever halide it will be formed. Now what is left behind? This two alkyl groups, right? So that will be forming RR dash, which is your alkane. Okay. Example, it is shown here, methyl iodide in presence of sodium and dry ether. Two molecules we have taken. See, CH3I, and you have 2 moles of sodium and ICH3. Okay. Now what happens? This much part will be removed. In presence of dry ether, what happens? You will get CH3 and CH3, which is C2H6. Ethane is obtained. Now what is removed from here? 2NaI, right? 2NaI, sodium iodide. So this is Woods reaction. So this is a very simple reaction, and it is a very, very important reaction also. Many times they have asked this in the question paper. Moving on to the next question, which is 44. Explain the mechanism of nitration of benzene. You have to write down the mechanism of nitration of benzene, which will carry 3 marks, and draw the staggered conformation of ethane. Staggered conformation of ethane. So first let's begin with the mechanism of nitration of benzene. So what does nitration of benzene means? Yes, we are going to add NO2, nitro group, to a benzene ring, right? So what are the reagents that we are adding, and how this mechanism is followed in detail we have to write. Okay. So benzene reacts with nitric acid and sulfuric acid. HNO3 and H2SO4 are the reagents that we use, right? Nitric acid and sulfuric acid to form nitrobenzene. It is an example of electrophilic aromatic substitution reaction. Okay. Electrophile is formed. NO2 plus, it is an electrophile, right? And it is a substitution reaction. Instead of hydrogen, NO2 will be substituted, right? One hydrogen atom of benzene ring is replaced with a nitro group. So one hydrogen will be replaced by an NO2 group, right? Nitric acid reacts with sulfuric acid to form nitronium ions. So let's understand the mechanism. So this, what we have mentioned here is OHNO2. This is HNO3 itself, right? HNO3. Okay, so just now we discussed in presence of nitric acid and sulfuric acid, this reaction will take place. So this is your nitric acid and this is your sulfuric acid. Now what happens here? As you can see, from the sulfuric acid, one hydrogen will be attached here. So that is what you can see here. That is the H plus which is getting attached here. Now in that case, when H plus is getting attached, means the oxygen will get a positive charge. Now in the next step, what happens? This will be removed as H2O. Okay, as you can see, H2O will be removed, and what is the electrophile you are getting? It is NO2 plus, right? NO2 plus. This plus charge will be also there, right? This is removed as H2O, so it is NO2 plus. So the first step is the formation of electrolyte, which is formed between the reaction between nitric acid and sulfuric acid. So NO2 plus is formed, right? Now what happens to the NO2 plus we are going to see. So this NO2 plus, which is the electrophile, is going to attack the benzene ring. So it attacks in this position wherein you already have an hydrogen atom, and the NO2 plus will be attached here. Okay. So as the NO2 plus is coming with a positive charge, that will be present on this carbon atom. Okay. So I hope till here it is clear. Now in this step we know that one hydrogen atom was being attached here. Now what else is left behind? HSO4 minus is left behind, right? Now that HSO4 minus will take up this H plus and form what? H2SO4. Okay, I hope it is clear. This HSO4 minus will take up this proton H plus, okay, will be removed. What we have to do, a hydrogen atom is being replaced by NO2, right? So this hydrogen has to be removed. That will be removed with the help of HSO4 minus. So that HSO4 minus is taking up one more hydrogen, means it will form H2SO4. Now what is only left here? NO2 will be left here. Hydrogen is being already removed. So I hope that is clear. So this is how nitrobenzene is formed. So what is the first step? First step is the formation of the electrophile that is formed between the reaction between nitric acid and sulfuric acid, wherein you are getting the electrophile NO2 plus. Now it will be attached to the benzene ring, wherein already one hydrogen atom is there. So from here, as you have HSO4 minus, that will take up this hydrogen and form H2SO4, which can be further used in this reaction. So this is the mechanism. Now moving on to the second part, what is the, or draw the staggered conformation of ethane. So what are the two conformations of ethane? One is staggered and one is eclipsed, right? So the question I've asked you only for staggered, which will give you 2 marks. A staggered conformation is a chemical conformation of an ethane-like molecule in which the substituents are at the maximum distance. When they are placed at maximum distance, that is called as staggered conformation from each other. This requires the torsional angle to be 60 degree. So this diagram you have to mention. So that will give you 2 marks. So as you can see, one carbon atom is present here. This carbon atom is having bond with 3 hydrogen atoms. What is the formula of ethane? It is C2H6, right? Okay. So this carbon atom, 3 hydrogen atoms, and this round represents another carbon atom to which you have 1, 2 and 3 hydrogen atoms. These 3 are hydrogen atoms of the middle carbon atom. Another carbon atom is represented by the circle, which will be having 3 carbon atoms. So as you can see in this case, all the hydrogen atoms are placed at maximum distance as possible. So the angle will be 60 degree. So in this case, when hydrogen atoms are placed as far as possible, it is called as staggered conformation. Okay. Now what is eclipsed conformation? We have already discussed, right? What is eclipsed conformation? In staggered conformation, hydrogen atoms will be present as far as possible or at maximum distance. Now in eclipsed conformation, these hydrogen atoms will be close with each other. Okay, so as you can see here, this is the 3 hydrogen bonds of this carbon atom. Now backside you have another carbon atom which is represented by the circle, and you know these are very close with each other and the angle will be 0 degree. Okay, if they are placed very close with each other, that is eclipsed, and maximum distance, it is called as staggered. Now one more type of conformation you can draw. Okay, this is called as your Newman projection. So you can either project or either show that in this format, that is this staggered format, or else you can write it in this formula, right? So as you can see here, CH3 one is mentioned here, and you can see another CH3 which is mentioned here. So in this case, this is example of eclipsed conformation, and this is how staggered conformation is there. As we have discussed, in staggered conformation, the hydrogen atoms will be placed as far as possible. As you can see, one hydrogen here, one hydrogen here, another hydrogen is present downwards. As you can see here, one hydrogen here, one hydrogen here, and another on the top, right? So they are placed as far as possible. But coming on to eclipsed, as you can see, one hydrogen atom is here, another hydrogen atom is here. So they are very close with each other. So this is another way of representing it. So either of this you can mention, which will carry you 2 marks. So by this we come to an end to the part D of the model question paper. So in next session, let us discuss part E of the model question paper, and by that we'll come to an end to the discussion of the model question paper 23-24. So I hope the questions that we have covered in this session is clear for you. So that's all for today. Thank you.